Hello everybody. This is my first tutorial using spoken English. I'm sorry for my English. I don't speak English. Okay, let's get started. My program description and documentation. At the beginning of the program, we include a documentation block called a doc string. This section explains the purpose of the application, which is to simulate a purchase transaction and calculate the exact change to return to a customer. It also describes the required input, the expected output, and include a reference to the project GitHub repository. Constant definition. Here, we define a constant message that will be displayed whenever the user enters an invalid amount. Using constant improves code readability and might feature modification easier. Available denomination. This list contains all available bill and coin denomination arranged in descending order. The program will use this value to calculate the exact change. Always starting with the largest denomination and working down to the smallest. Separator length configuration. This constant defines the length on the separator line used throughout the program interface. Centralizing these values allows us to adjust the visual formatting from a single location. Requesting a positive amount. This function is responsible for requesting a monetary amount from the user. It validates the input to ensure that only positive numeric values are accepted. Validation loop. The function uses an infinite loop that continues asking for input until a valid value is provided. Input conversion. The user input is converted into a floating point number, allowing the program to handle amount that might contain decimal values. Positive value validation. If the enter amount is 0 or negative, the program displays an error message and asks the user to try again. Returning the valid value. Once a valid positive number is entered, the function returns the value to the calling code. Handling invalid input. If the user enters text or any non-numerical value, a value error is triggered. The exception is handled gracefully, and the user is prompted to enter a valid number. Separator function. This utility function prints on a horizontal separator line made up of equal sides. It helps improve the visual appearance of the program's output. Displaying the program title. This function displays the application's title and decorative separator, creating a cleaner and more user-friendly interface. Calculating exact change. This function calculates the exact change that should be returned to the customer. It uses a grading algorithm, always selecting the largest possible denomination before moving to the smallest one. Create dictionary. An empty dictionary is created to store each denomination and the corresponding quantity required. Iterate through denomination. The program iterates through all available denominations, starting with the highest values. Check applicability. For each denomination, the program checks whether it can be used to cover part of the remaining change. Calculate quantity. Using integer division, the program determines how many units of the current denomination are needed. Or they remain unchanged. The value covered by the selected denomination is subtracted from the remaining change. A stored result. The denomination and each quantity are stored in the dictionary for later display. Return dictionary. After processing all denominations, the function returns the complete chain breakdown. Displaying the chain breakdown. This function represents the final chain distribution to the user. Iterate through result. The function looks through the dictionary and displays each denomination along with a number of bits or coins required. Main program function. The main function coordinates the entire workflow of the application. Display title. The program begins by displaying the title and welcome interface. Request purchase amount. Next, the program asks for the total amount of the purchase. Request payment amount. The cashier then enters the amount paid by the customer. Validate payment sufficiency. The program checks whether the payment is sufficient to cover the purchase. Calculate short age. If the payment is insufficient, the missing amount is calculated. Notify user. The shortage is displayed and the program terminates without attempting to calculate change. Calculate total change. If the payment is valid, the total change to return is calculated. Display change amount. The program displays the exact amount of change owed to the customer. Determine whether change is needed. The program checks whether change must be returned. General breakdown. If change is required, the program calculates the denomination breakdown and displays the result. Exact payment. If the customer pays the exact amount, the program informs the user that no change is necessary. Farewell message. Finally, the program displays a thank you message completing the purchase simulation. Program entry point. This is the program's entry point. The condition ensures that the main function runs only when the file is executed directly and not when it is imported as a module into another Python program. In summary, this application demonstrates input validation, function decomposition, conditional logic, loop, dictionary, and the implementation of the grading algorithm to calculate exact change efficiently. It provides a practical example of how Python can be used to solve real-world transaction scenarios. Okay, this is my overview on the program. Here we can see how it works. Run. Okay. This is my title, Purchase Simulator with Exact Change. First, enter the total amount of the purchase. Example, 0. You cannot enter 0 or a negative value. -1. Here we can see the same measure for negative value. Letter. Please enter a valid numeric value. Okay. Now enter the amount paid by the customer. 0 for text, -1 for text, letter for text. Okay, 5,000. Okay, total change to return 0. No change is due. Thank you very much for your purchase. Okay, the same value for amount of the purchase and paid by the customer. Okay, now 5,000 and 4,000. Insufficient payment. You are sure by mail or by 1,000. Okay. Now run current script. 1, 2, 3, 4, 5 and 5, 4, 3, 2, 1. Press enter. Total change to return 41976. Give the customer 2 bills of 20,000, one bill of 1,000, one bill of 500, two bills of 200, one bill of 50, one bill of 25, and one coin of 1. Thank you very much for your purchase. When I'm sorry for my English, but this is my final project for Coding in Play 2026 by Stanford University. See you later, dear friend of mine.